All right, we're going ghost hunting today, but forget the haunted houses. We're hunting for ghosts in the machine. We're going to tackle a massive, kind of hidden challenge in artificial intelligence, figuring out why the world's most powerful AIs break in the most mysterious ways. So, have you ever wondered about this? I mean, this is the very question that literally keeps AI developers up at night. And we're not talking about simple typos in the code here. No, no. These are ghostly, totally unpredictable errors that can just flicker into existence and then, poof, vanish, leaving zero trace. It's what makes debugging these systems so incredibly hard. Now, to really get why these ghosts even show up, you've got to wrap your head around the sheer scale we're dealing with. See, a distributed AI isn't just one computer. It's a huge network of maybe thousands of machines, all working together like one colossal brain. Imagine a single mind, but its thoughts are zipping across an entire city. That's the kind of crazy complexity we're up against. And that is why this whole thing is a detective's worst nightmare. I mean, seriously. When a bug happens, the crime scene isn't just one room. It's spread across 1,000 different locations all at once. The one clue you need, that one little line of faulty code, or that single piece of bad data, it could be hiding anywhere among billions of operations. Where do you even start looking? So, yeah, that nightmare, it really boils down to three huge challenges. First, that massive scale we just talked about. Second, and this is where things get really trippy, is something called non-determinism. Think about that. It means you can do the exact same thing twice and get a totally different result. It just flies in the face of everything we think we know about how computers are supposed to work, right? And third, you've got data complexity. The AI is always seeing new, unpredictable stuff, and any one of those inputs could trigger some hidden flaw. So, faced with all this chaos, how in the world do you even begin to fight these ghosts? Well, engineers have developed a pretty specialized toolkit, kind of like their secret weapons. So let's open it up and see what's inside. We're going to look at the core strategies they use to hunt down these elusive bugs. First up, we've got something called observability. Basically, it's the power to see inside that black box while the whole thing is running. By collecting this constant stream of digital clues, metrics, logs, data traces, engineers can piece together what the AI was thinking at the exact moment it all went wrong. It's all about making the invisible visible. Okay, so seeing clues after something's already broken is great. But what if you need to poke and prod the system without risking the real live thing? That's where the next tool comes in: simulation. Engineers literally build a perfect digital twin of the entire platform. It's like a safe, virtual playground where they can replay failures over and over, test out their craziest theories, and try fixes until they finally crack the case. When you think about it, these two strategies are really two completely different ways of thinking about debugging. Observability, that's reactive. It's like performing an autopsy after a failure to find the cause of death. But simulation, now that's proactive. It's like running a health screening on that digital twin to find and fix problems before they can ever cause trouble in the real world. Okay, so this all sounds super technical, right? But why should any of us really care? Why does this matter beyond the world of coding? Well, it's because getting this right has enormous consequences for, well, all of us. This isn't just about fixing software. It's about building a future where we can actually trust the most advanced tech humanity has ever created. For starters, it just massively speeds up progress. Check this out. Teams that use these advanced techniques, they can solve these ridiculously complex problems up to 50% faster. That's not a small jump, that's a huge leap. It means way less time hunting for ghosts in the machine and way more time actually inventing the future of AI. And all that speed, it ultimately leads to something even more important: reliability. I mean, think about it. When AI is driving our cars or helping doctors diagnose diseases, 99% reliable just doesn't cut it, right? The goal has to be something crazy, like 99.9%, near perfection. And it's this advanced debugging that actually makes that possible. It's the bedrock, the very foundation for building systems we can literally trust with our lives. All right, so let's boil this all down. What are the key things to remember? First, debugging this stuff isn't just a technical task. It's a creative science, a true investigation. Second, these strategies, they're both a shield and a rocket. They make AI safer, and at the same time, they let us innovate way faster. And finally, and this is the big one, as AI keeps getting more and more powerful, our tools to fix it have to keep up.
And that leaves us with one last really big question to think about. We're basically in an arms race, right? Between how complex AI is becoming and our ability to actually control it. The tools we have today are, frankly, brilliant. But as AI keeps growing exponentially, are they meant to be enough? Honestly, that might just be the single biggest challenge facing the next decade of technology.